So a little about partial pressures. If you want the total pressure in some container or in the atmosphere, it's going to be the sum of the pressures of the gases that are present. So like right now we're at 1 atmosphere of pressure, approximately 1 atmosphere, and that's about 0.78 atmospheres from nitrogen, about 0.21 atmospheres from oxygen, about 0.01 atmospheres from argon. Right, those are some approximates, but the pressures of the gases, individual gases, if you add them together, you get the total pressure. Just to point out, if you wanted P1, if you wanted P of some individual gas, you just use PV equals nRT. P equals nRT over V. So, right, we could substitute that in here, and we could substitute this in here. Right? If we know the number of moles of this gas, and the number of moles of this gas, we can solve, and we'll get a P total. So anyway, oftentimes when you're dealing with these problems, the question might ask you about a dry gas and a wet gas. And so if you're talking about that, it's just that the wet gas includes water vapor. So we'll look at a problem like this. So we're a sample of gas that is collected over water. Since it's collected over water, and water has a tendency, water evaporates, right? There's going to be a vapor pressure, there's going to be a pressure of water, gaseous water. That's going to make a wet gas. So, sample of gas collected over water at 42 degrees Celsius occupies a volume of 1 liter. The wet gas has a pressure of 0.986 atmospheres. So just to point out, this wet gas has 2 gases present, 1 gas and the water. The gas is dried, and the dry gas occupies 1.04 liters with a pressure of 1 atmosphere at 90 degrees Celsius. Calculate the vapor pressure of water at 42 degrees Celsius. So the dry gas only has 1 gas. So there's not this situation where there's multiple gases. When they tell you that they have a dry gas, that's its own thing, so you can use PV-nRT and you can kind of simplify things. So you could try solving that, and in a second I'll show you a solution. Alright, so first question that I wanted to answer, right, here's the dry gas, information on the dry gas. Pressure is 1 atmosphere, volume, and the temperature. Remember, you need Kelvin for any time you're dealing with gases. So I want to know how many moles of dry gas do I have? If I know the number of moles of dry gas, that's the same number of moles as before when the water was there. So I do PV equals nRT and solve, and we get 0.039 moles of dry gas. And then, okay, well, what was the pressure initially of that gas, right? The initial pressure they told us was 0.986 atmospheres. That pressure came from 2 gases. It came from that dry gas, whatever that is, and it came from the water. So if I can figure out what the pressure, what the dry gas contributed to that, I can answer the question. So pressure of the gas initially, the initial volume was 1.00 liters. The initial temperature was 42, and again, don't forget to convert to Kelvin. We get 315, and now we plug in the number of moles that we just found, and we solve for pressure. We get 0.902 atmospheres of pressure. So now it's easy. The total pressure was consisted of the pressure of the gas plus the pressure of the water in the gaseous phase, 0.986 atmospheres. And so your 0.986 minus the 0.902 of the gas gives you 0.084 atmospheres for the pressure, vapor pressure of water.